We're on page 53 looking at lesson 9, the distance formula. Um, if we're looking at a number line, then the distance between 2 points on a number line can be found by using the absolute value of the difference, subtraction, of two of both points. So say we have 1 point on the number line as -7, 1 point on the number line as 18. Well, we simply have to do the absolute value of the difference of the 2 points, and it doesn't matter which one is first or second. I'll do 18 minus -7, absolute value. 18 minus -7, well, that would end up being 2 negatives equals a positive, so that would be 25. Okay, if I had 7, absolute value, or -7 minus 18, and I had that as the absolute value, that would be an -25 absolute value. Remember, absolute value is the distance from that number to 0, so it would be 25. It's always positive. So that would be how you solve for a number line that is horizontal or vertical. But let's say we have two coordinates on the coordinate grid, such as right here. We have coordinate 1, 2, and we have the coordinate 4, 6. How would we find the distance of that? It's a diagonal line, slanted. We have what is just simply known as the distance formula. It looks like a lot, but it's really not too difficult. You probably want to go ahead and memorize this. This will be used throughout the future of geometry and even further math classes. But in order to find the distance between two coordinates, distance equals the square root of x of 2 minus x of 1 squared plus y of 2 minus y of 1 quantity squared. And if we broke it down further, it's basically just a form of the Pythagorean theorem that we did in the last lesson. But let's go ahead and plug these numbers in. So we have coordinate, in example 2, we have 1, 2, and 4, 6. We have those two coordinates. Either one of these can be the x of 1. I'm going to go ahead and call this one the x of 1, therefore making this the x of 2. Now, where you have to make sure that you always get this part of the equation right is if this is the x of 1, then this has to be the y of 1. If this is the x of 2, then this has to be the y of 2. The coordinates have to correlate and correspond when they are plugged into the formula. So we plug it into the formula. X of 2, 4, minus x of 1, 1. Quantity squared plus y of 2, 6, minus y of 1, 2, quantity squared. And then all that's square rooted. And then let's go ahead and do the distance, or keep solving in the algebraically. 4 minus 1, solve in parentheses first. 3 squared. 6 minus 2, 4 squared. Square them, add them together. 9 plus 16 is 25. And remember, all this is square rooted. So the square root of 25 equals our distance. Therefore, distance equals 5. And that is the distance formula. If you did have, I know in the next example it just looks something like this. Say you had coordinate 3, 3 and -2, 3. And it's a straight horizontal line. They actually have the same y value. If you had that, you could actually ignore the y values and just do the absolute value of the difference of 2 points, just like we did before. So you could do -2 minus 3. Absolute value, find that it would be 5. But if it's horizontal, straight up and down, vertical, you do not have to do the full distance formula. You can save yourself a little time there. But that is the distance formula, and that's all there is in lesson 9. It just looks like a big formula, but it's really not too difficult, and the math is pretty simple when you plug it in. Next, I want to look at lesson 10, conditional statements and converse statements. A conditional statement, and this is logic, proof type stuff, but a conditional statement is the form of if P, then Q. Now what P stands for is the hypothesis. What Q stands for is the conclusion. So if we have if P, then Q, if we were looking at a quick example here, this says if an angle is obtuse, then it measures 120 degrees. So what is the hypothesis? The hypothesis, or the P, is what follows if and is before the then. The if is not included. This is your P, or hypothesis, making the rest of the statement that is after the Q your conclusion, or the Q. So that is, in a nutshell, a conditional statement. A converse statement, the next type of statement we'll look at is a converse statement, and that is simply the conditional statement swapped. Converse statement says if Q, then P. So what you would have is you would start with your conditional statement, say this is our conditional statement. Okay? That's our conditional statement. We've got our if P, then Q. If we wanted to turn it into a converse statement, what we would have to say is if an angle measures 120 degrees, then an angle is obtuse. So we would simply switch them. We turned it from a conditional to a converse statement by switching the if P, then Q. And that's all you do for a converse. So I know in example 3, it says, write the converse of each statement and determine whether the converse is true. So now we have to figure out if the statement is true. So this says, if an animal is a dog, then it has 4 legs. Well, most dogs have 4 legs, although I did see a 3-legged dog this past weekend. But if an animal is a dog, then it has 4 legs. That is your conditional statement. Our converse statement, it asked us to write the converse, would be if, and this is our P, this is our Q. Converse is if Q, then P. So if a dog, if we're referring to animals, an animal has 4 legs, then our conclusion, it is a dog. So that would be our converse. Now, is that true? If an animal has 4 legs, then it's a dog. Well, no, that's not necessarily true, because I know a lot of other animals, such as a cat, that has 4 legs, but it is not a dog. But that is the definition of a converse statement versus a conditional statement. Using simple logic, and we'll look at more statements in the future, but these are the initial starter ones. And that is all that there is to lesson 10. I want to really quickly look at Investigation 1. Investigation 1 can be found on page 63. That's the beginning. And it's just transversals and angle relationships. A transversal The definition of that is a line that intersects two or more coplanar lines at different points. So I have my little figure drawing here. I have two lines that are drawn, don't have to necessarily be parallel, but they're drawn, and then this line right here intersects both of these lines. That is the transversal. Just intersects both lines, that's all it is, that's all you got to know. So now looking at a couple of angle relationships that we can know because of transversals, we have, we're just going to look at 4 different ones in this investigation. First one is corresponding angles. Right here we have, if we called this angle 1 and angle 2, those would be known as corresponding angles. And this, you have lines that are parallel that are cut by a transversal. These do have to be parallel lines. But these are corresponding angles. Corresponding angles are always congruent. The next relationship you have is alternate interior angles. And you can see 1 and 2. It's on the inside, in a sense, of the two lines. On the alternate opposite sides, those are congruent as well. Alternate exterior angles, 1 and 2, outside of the two lines, those are congruent. You have same side interior angles. Same side interior angles are a little bit different. We've looked at 3 congruent ones, but same side interior angles they're different than alternate because they stay on the same side, so therefore they are actually supplementary. They would form to be, they would add up to be 180 degrees. And if you saw something like this, I know we've looked at things like this, angle 1 and 2 there, hopefully you remember what those are. Those are vertical angles, and those are congruent. We also have, I think one more, 1 and 2 there. Those are what we call a linear pair, and those are supplementary. So when we say we had an example problem where we had 2 parallel lines, we knew that this angle was 60, and it wanted us to find this angle, call it x. Well, we would know that once we have these memorized, we would know that these are same side interior angles, and same side interior angles are always supplementary. So if they're supplementary, add up to be 180, so therefore 180 minus 60, x would be 120 degrees. And that's all investigation 1 is. Just a couple of definitions to know when we're looking at angle relationships with transversals.